Tensors, a topic in math and physics that isn't really discussed much, yet is also one of the most common parts of it. You don't hear many gawk at the importance of them like they do with things like nuclear fission or the quadratic equation, which are both talked about so much it becomes annoying. Like, yes, I know you're smart, please leave my house now. Anyways, I feel like showing the tensors some love today, which is the topic of this video. Oh, yeah, explained via Minecraft. Enough yap, let's go. Okay, so what exactly is a tensor? So to explain tensors, I must first tell you guys about vectors. To recap your high school physics class, vectors are basically instructions that transform a certain point over a certain magnitude and direction. If we have a vector that says to move a block 3 up and 2 to the right, we'd be able to reuse that vector no matter where the block's position is on the plane. Why is this useful, you may ask? Well, tensors primarily use vectors in calculations, so knowing how vectors work are essential for understanding how tensors work. Now that we know some basics about vectors, we can now explore tensors. First off, let's look at this wool block. For no reason, I'll name him Greg. Now, Greg is not on a coordinate grid, only merely existing as a single number. Greg is what is known as a rank 0 tensor, which only represents a single number. Greg is what's known as a scalar, as they don't have a direction given to him. Now you may be thinking, wait, why is our boy Greg over here a rank 0 tensor? Well, the ranking of the tensors relate to the amount of indices required to choose a desired value inside a tensor. Since Greg is only one value, he doesn't need an index to choose his values. And Greg is also zero-dimensional in this case, in lieu of his one singular value and his lack of being on a coordinate grid. But being zero-dimensional bores Greg, so let's put him on a 3D Cartesian plane. Greg can now move, unlocking 2 extra values in the process. Greg has turned into a rank 1 tensor, which you can represent as Greg with a superscripted mu. What does mu mean? Well, that refers to a single of Greg's indices. Greg has an x-coordinate, y-coordinate, and z-coordinate, allowing him to move in a 3D world, also meaning Greg is a 3D tensor. And if we say that mu was equal to 0, for example, then we'd be directly asking for the x-coordinate, since that is at position 0. But this doesn't satisfy Greg's want for more forces. Each of his original points have another point attached to it, being independent to the other point beforehand. Greg has now become a rank 2 tensor, or more simply, a matrix. Greg has grown an extra symbol on the side of his head, which is now new. Since Greg is in a 3D world, he now has 9 possible components in his body. Since to calculate the amount of components he has, it is dimension to the power of the rank, or d to the r, or m to the m if you're picky. In this stage of Greg's tensolution, see what I did there? Greg has to have 2 indices for IDing a force. Mu now is considered his row index, and nu is considered his column index. Greg now has the capability to compare multiple vectors and how they interact. Since we're going off of normal coordinate points, let's say that Greg also has a force vector associated with the x, y, and z axes. Here is a diagram of matrix level Greg. Amidst some possible errors I made, this matrix shows that the force vectors and coordinate vectors create a force position value. Each value is a tensor product and is represented by a circle with an x in it. For Greg's EX form, let's add another quantity vector. Let's say Greg is also considering displacement. Real quick, displacement is the distance and direction a thing has moved from their initial point. Say a cow moves from point I to point J. He moves along a rail system, so he covers around 10 blocks, but in actuality he only moved 5 blocks to the right. Anyways, Greg EX is now a rank 3 tensor. Greg has indices mu, nu, and sigma. Rank 3s work very similar to rank 1s, but with the extra dimension. Greg can go beyond just rank 3. Greg can become a GX, Mega, or even God tier tensor, all by just adding an extra index to Greg's indices hat. Another aspect of tensors is their ability to be used in transformation equations. Tensors are able to be combined, transformed, and manipulated by following some rules similar to how normal numbers behave. Say for rank 2 Greg, he meets his soulmate, Greg et. After falling deeply in love and getting married, they have a kid, Greg Jr. When Jr. becomes an adult, his matrix values are the outer product of his parents' values. Here's how the equation would work. For each value in the matrix, you'd find the product of Greg's values and Gregette's values. But when Greg Jr. is a baby, he is instead the dot product of his parents. In this form, the diagonal values from his adult form are added together into a single scalar quantity. Since the diagonal values share identical indices like xx, yy, and zz. Those are some possible things that tensors like Greg can perform. Now that I've explained what tensors are, how are they used exactly? Simply put, tensors are everywhere. In general relativity, they're used to denote changes in reference frame between different observers. In machine learning, tensors store tremendous amounts of data to learn from. In fluid dynamics, they're used to calculate a fluid's velocity and stress on other objects. I can go on, but I think you can tell they're kind of important and omnipresent in all areas of math, but I don't know though. So those are tensors. They're a way to hold and calculate a lot of values into a single value, which are then accessed by basically plugging in the position a value is at. I hope you guys enjoyed as much as I did researching it. This is a really general overview of tensors. They are much more complicated than this, with way more properties to learn, but I think this is a good starting point for most people. Anyways, hope you all have a good day. See you nerds next time.